So today we're going to talk about dividing complex numbers and rationalizing the denominator. So that's literally our I can statement. I can divide complex numbers and rationalize the denominator. So that's literally the I can statement for taking notes today. So what we need to understand is fractions first. So like if I have 1/2, that means that I have one pizza and half of it is left. Okay, so we can actually, fractions are things we should be able to visualize in some way, shape, or form based on the denominator. Now when I look at this denominator here, there's no way to visualize that. We have an imaginary space, meaning that imaginary numbers in the denominator don't make sense. So we need to remove the imaginary number out of the denominator. That's our goal today, okay? Because right now it doesn't make sense. There's no way to visualize that denominator. So our step one is to identify the conjugate. If I can spell it, so J-U-G-A-T, conjugate. So what we're going to do is this right here has a complex conjugate, and all it is we switch the sign. Notice there, this is plus, and that is minus. Okay, and that is the conjugate. So we just basically take the denominator and switch the sign in the middle. Step two, we times top and bottom by the conjugate. Okay, so we're going to times the top by 5 plus 2i and the bottom by 5 plus 2i. We can do that because that's just 1. If we do 5 plus 2i divided by 5 plus 2i, it's 1. So we're actually just multiplying this fraction by 1. And so what that's going to do is we're going to distribute on top, and we're going to FOIL here. So we're going to FOIL the denominators. If you need help with that. Okay, so I'm going to start with the numerator. So I'm going to distribute this in. So I'm going to get 20i plus 8i squared. And then the bottom I'm going to FOIL. So this 5 is going to go to both. So I have 25 plus 10i. And then the 2i is going to go to both. Negative 2i. So I'm going to get minus 10i minus 4i squared. And if we did this correctly, these will always cancel when we do this. So what's left is 20i plus 8i squared over 25 plus minus 4i squared. And then we're going to take our I squareds and put negative 1s in. So that's going to give us 20i minus 8 over, it's a positive, so 29. Negative times negative is positive. Now to help just simplify things, to make things look more like SAT, because this is the answer, and we can stop there in a lot of cases. But on the SAT, they always put the number first, so the negative 8 comes first. And then they always put the imaginary number second, and they divide out these. So this is how this would look on the SAT, and they would reduce the fractions if we could. Now we can't reduce these, but if we could reduce them, they would. And so that's what we're looking at on the SAT. That's what the answer would look like. Very similar. They just switch the numbers around and separate the denominators. Okay, that's how you do it. Now this one is no different. Can we visualize root 5? No, we can't visualize root 5. It doesn't make any sense. But if I had like 1/5, I could have a pizza with a fifth of a slice left with, 4 blanks. And so that'd be a fifth right there. But I can't visualize or draw a root 5. It doesn't make sense. And so we need to get rid of the denominator. And so whenever we deal with roots, we do the very similar thing where we just times it by the root on top and bottom. And what that's going to do is we always multiply roots with roots. So numbers and roots don't go together. That's why they get tacked on next to each other. But roots times roots we can do. So we'd get that. And then the square root of 25 is 5. And then that's how we do it. So we have 7 root tenths of 5 pieces. And so the root 10 is a little bit bigger than 3. So we have 21 fifths basically, or we have like 4 pizzas and 1 more slice basically is what that is. And so we can actually visualize that. Whereas before this answer, there's no way to visualize this root 5. It's a point of a decimal, which doesn't make sense because fractions, the denominators need to have a visual with them, and we can't do that with the root 5. So that's why we have to do that. So this is my last example in this video, and it follows the same procedure here. So we're just going to use conjugates again. So it's the same procedure as our first one, but we're doing with roots instead of imaginary numbers, but the rules are very similar and the same. So we're going to times by the conjugate of 6 plus root 3 is what that's going to be. So notice, again, with conjugates, this is a minus. This is a plus, and that's all it is. So when we talk about conjugates, that's what we're talking about. And then here, we're going to take this, so we're going to distribute to both on the top here. So we're going to get 18, and it'll be 3 root 3, because roots and numbers don't get along. And there's the negative up front, so we're not going to forget that. And then the denominator we're going to FOIL. So 6 goes to both. So we're going to get 36 plus 6 root 3, because again those root 3's and numbers don't get along. They're not kosher, I guess you want to think about that that way. Ooh, I messed up there, so let's put that back. And then this root 3 is going to go to both, so we're going to get minus 6 root 3 because it's negative, and then negative root 9. Now if we did this right, these will cancel. The top, there's nothing to do, it's all simplified. So we're just going to bring that down, there's nothing to do there. And we're going to get 36 minus, and then this is 3. So I'm going to bring that down. And so we're going to get 18 plus root 3, or 3 root 3 over 33. I'm going to circle this because if you got that far, I'm pretty happy with you. I'd give you a B for that, for sure. But again, on the SAT, they're going to go another step or two. So they're going to separate this out. Now again, when we're looking at this, we're looking just at the numbers here. So this right here in green is what I'm looking at. That root 3 is just kind of just hanging out. Doesn't really do anything for us right now, and it won't. So on this side, we can divide top and bottom by 3. So we're going to get 6 over 11. And on this one, we can get 1 root 3 over 11 because we can divide this by 3 and this by 3. And we don't necessarily need to write this 1 in front, and so I'm going to erase that here. And that would be the answer that we'd look for on the SAT. So notice that they're the same thing, it's just they're separating them out and then they're dividing top and bottom to reduce, and that's how it works. And don't forget that negative in front. I almost got a wrong answer here because this is a negative and because of the negative there. So okay, that's how you do this. And remember, the whole point of this is because we need to have something that we can visualize. And again, I made another mistake here because this is going to have a negative on it too. And the reason being is because of the negative up top here. So anyways, if you have any questions, let me know. Good luck.